Hello, my name is Dinesh and today we are going to talk about DMVPN Phase 3. So let's get started and jump into this. DMVPN Phase 3 actually was introduced by Cisco, and this was designed because we had some disadvantage in Phase 2. So Cisco designed to fix some disadvantage we found in Phase 2. Specifically, these issues include like scalability, performance issues. If I talk about DMVPN Phase 2, that allows hub daisy chaining. So when you have any traffic between spoke to spoke, first it goes to hub and hub sends resolution message to spoke and resolve the IP address for another spoke. In the case of OSPF, we have some limitations if we configure DMVPN Phase 2 because point to multipoint does not work well in DMVPN Phase 2. If I talk about scalability, in Phase 2, summarization is not allowed on the hub. So all the prefixes must be distributed to all the spoke to be able to set up direct spoke to spoke tunnels. So all the routes must be more specific, otherwise you cannot send or you cannot make direct spoke to spoke tunnel. So summarization generally not allowed on hub. If you summarize anything on a hub, that means you are gonna have the behavior as you have in DMVPN Phase 1. Performance wise, if we talk about in DMVPN Phase 2, is when you want to send packet between spoke to spoke, one time it has to go through hub, so kind of CPU intensive we can say. But what other remedies we have in DMVPN Phase 3 are, I can say there are two types of messages included in Phase 3. One is NHSRP redirect, second is NHSRP shortcut message. So redirect message generally generated by hub to tell all the spoke you may have better path for another spoke or for your destination instead of sending packet to me. The NHSRP shortcut, this is a kind of a changing mechanism I can say, or a new way of changing or overwriting safe table. So when you want to send packet between spokes, you are gonna overwrite safe table if you are using DMVPN Phase 3. The Phase 2 generally, in the Phase 2 generally we send registration request to hub and hub resolves the next hop tunnel IP for us. So hub is working on behalf of the spoke to resolve the next hop tunnel IP. In Phase 3, we have here called NHSRP new route in the routing table. So if we want to send packet between the spoke, in Phase 3, new NHSRP route is installed in the routing table that tells the spoke how to reach the remote spoke at the other end instead of sending packet to hub. We have advantage like NHSRP registration request to hub. Of course, we have in Phase 3 spoke to spoke resolution via NHSRP. We have on-demand tunnel between spokes, tunnel mode GRE multipoint. In all the spokes including hub, we have to define tunnel mode GRE multipoint. In this case, next hop can be updated in DMVPN Phase 3 if we can see OSPF point to multipoint network, then we will see next hop will be updated by hub. NHSRP redirect from hub. Hub is gonna have the command NHSRP redirect to tell all the spokes you can talk to each other without sending any packet via me. Trying to resolve NHSRP for final destination. So green router now is not gonna point the hub for sending packet to red router. Green router will directly have the route installed in the table to send packet to red instead sending it to hub. NSSRP trying to resolve the destination IP, not trying to resolve the hub IP. Summarization default routing is allowed at the hub this time. You can summarize, you can generate default route from the hub, but actual working process or the actual traffic flow will be based on the NSSRP resolution. So that can be based on the SAF table, is not based on always based on the routing table. Some limitations we can have, like next hop is always changed by hub in the RIB. So we will see that in the configuration part when hub is gonna update the next hop and is not gonna preserved or preserved. So we will see in the configuration part now. So let's go to the configuration part and jump into our topology and understand the scenario. We have this topology where all the IPs are already configured. We need to configure tunnel. So I'm gonna implement EIGRP and going to run EIGRP in all the devices. Before that I need to set up phase 2 tunnel. So first we understand the behavior of phase 2, then instantly we will update phase 3 and understand the behavior of phase 3 with EIGRP. So some commands are simple: interface tunnel 123, IP address for hub, tunnel source, tunnel key, IP NSSRP authentication, tunnel mode GRE multipoint, IP NSSRP map multicast to support multicast, IP MTU because we don't want to mismatch with MTU value when we want to send a large packet. I'm giving two extra command here because I'm going to implement EIGRP along with this. So I'm implementing two command: IP split horizon, no IP split horizon EIGRP 100, and no IP next hop self EIGRP, because again we don't want EIGRP to work like EIGRP working in DMVPN phase 1. So the next hop should be preserved in EIGRP. Then we give this command: no IP next hop self EIGRP. So hub is not gonna update the next hop value. Let's go to red router and first configure the tunnel. I go to red device here, type tunnel mode GRE must be multipoint. So I'm configuring here DMVPN phase 2, tunnel mode GRE multipoint, tunnel key 123, IP NHSRP authentication Cisco 123, IP NHSRP map, mapping with private IP to public IP of hub, IP NHSRP map multicast public IP of the hub, IP NHSRP network ID, IP NHSRP the next hop, private IP of the hub, and MTU value. Go to green device and configure the tunnel. So hub, we can see hub is disabled with a split horizon. IP address, tunnel source, tunnel mode GRE multipoint, tunnel key, authentication, mapping between private to public IP of the hub, mapping of multicast. When I am going to send multicast packet, I will send it to hub device in unicast format, network ID, next hop server, and the next hop server, and these 3-4 commands are most important. Let's configure EIGRP first in hub. So the configuration of EIGRP is simple: router EIGRP 100, 192.168.1.0, network 1111, no auto summary. That's it. Go to red router and configure EIGRP. Router EIGRP 100, 192.168.1.0, 2222 and 25.0 as well. Green router will have same type of config. Then gonna configure edge router. After that, go to edge device and configuring EIGRP, router EIGRP 100, network 192.168.34.0, network 4.4.4.4, no auto summary. You can give the wildcard mask or the subnet mask here, but I am simply defining as I am comfortable with. And we can see that our neighborship has come up in hub router, and go to green router and verify show IP route EIGRP, and we can see that if I want to send packet to 2222, which is green router, and next hop is preserved, it's not updated by hub because we had defined this command. This command is disabling the next hop update behavior on the hub. Okay, green router, if I can see show IP route 2.2.2.2, and I can see I learned from 192.168.1.1. This is the originating router, which is my router 2, red router. If I want to trace route here, I can send packet to 2.2.2.2. This will go, first time this will go via hub, next time it will make the direct tunnel, because the hub will tell if you want to send packet to red router, I am resolving the red router's tunnel IP for you. You can directly send packet to red router. So it's going first to hub, then it will end with red router. Okay, again I'm trying. So this is going here. Now we can see it's directly going to the next spoke. What I'm going to do in this phase 2, if I generate a default route from hub, it's not allowed, but still I'm gonna do here. So that will not give the behavior what we want. So go to tunnel, IP summary address EIGRP 100.0.0.0.0 and generating default route. This will now tell all the devices that you remove all your more specific routes and install default route in your routing table. So if I say show IP route EIGRP, and I can see there is only one default route we are learning from hub. But this time when you ping the next device IP like 2222, the always we can see here is traffic will travel via hub because we don't have more specific routes. So that is the disadvantage using summary on the hub. So summarization is not allowed. You are totally losing the visibility of your network and you are getting the behavior as you are working in DMVPN phase 1. So we don't want this type of behavior. We want something else that we can get in phase 3. So I'm not gonna remove the command summary command. I will keep the summary command as it is. If I see here show IP route 2222 is saying I don't have this route in routing table, but if I say show IP safe, where this router is pointing to, this router is pointing toward 192.168.1.1. So if I am looking for 2222, I am taking decision based on safe table because I don't have proper route in routing table. So let's configure phase 3, and in phase 3 summarization and default routes, all the things are allowed at the hub. I have the default route, I keep the default route as it is. I'm gonna give the command here is called IP and HSRP redirect command on hub. Before that, if I want, I can enable debugging and I say debug NHSRP, and so on hub you give IP NHSRP tunnel, IP NHSRP redirect. On spokes you can give the command shortcut command. So on both the spokes, interface tunnel 123, IP NHSRP shortcut, that's making our DMVPN phase 3. Interface tunnel 123, and here is the output. Now if I say I want to send packet again from green router, if I say trace route 3.2.2.2.2, and this time I can see the packet, first time packet will go to hub, the next time it will directly go to red router. So let's see, after configuring two commands, what is happening. Even though we have summarization and default route originating by hub, we are now taking decision based on the safe table. So one time is going to hub, the next time it will go to spoke directly. So NHSRP resolution process is happening here for direct destination, and we are going to have here new route, NHSRP new route in our routing table. So we can see the output. If I go to hub, hub is saying I can verify a message, receive resolution request. We must have attempting here, enabling NHSRP redirect feature after giving this command, attempting to redirect remote location. This is my remote NBM address, public IP, and going to 2.2.2.2. So inserting now this source, this destination means green router and the loopback of red router in redirect table, and attempting to send packet through interface tunnel. So I'm sending and telling, okay, if you are looking for 2.2.2.2, you can send packet directly, sending NHSRP control packet, receive resolution. This will happen again and again, but finally the redirect message went to the spoke, and spoke now has the table. So let me verify this time. If I say show IP route 2.2.2.2, and I can see known via NHSRP, we are running EIGRP, but this route is installed by NHSRP protocol. NHSRP resolved, automatically resolved the next hop IP. If I want to send packet for this, I am directly gonna send packet to this instead of sending it to hub, and the AD value for that is 250. So traffic is not flowing through the hub, traffic is directly flowing to the spoke, and this is happening because of the new route installed in the routing table, and that is because of the NHSRP protocol. So in the scalability point of view, I can have true destination resolution, or like we can say we are overriding here, we are riding the next hop, we are overriding the next hop. So I can install on the spoke only a default route and resolve longer needed prefix on demand via NHSRP. Like this, if I say show IP route EIGRP, and we can see that we have 0.0.0.0 route, but we don't have more specific route. So what is happening here, we are overriding the next hop, and default route we are learning from the hub router, but we have this route as well in routing table, and that is via NHSRP. If I look for, I can say is that show IP route 2.2.2.2, that is via NHSRP. So again if I want to send packet trace route 2.2. And we can send that. So it doesn't matter when you're looking for the specific route. First the spoke router is going to resolve the next hop value using NHSRP, looking for a particular destination. If that is available in all the routers routing table, then there is no issue. Then packet will go to hub and hub will resolve the query for all the spokes. This is the scenario of EIGRP when we have default route coming from hub and we want to send packet to another spoke, and we don't have the entry about that particular spoke's route in our routing table, but still we can resolve the next hop IP using NHSRP. That is the solution we have in DMVPN Phase 3, and more advantage because default route and summary is allowed on the hub. So let's remove now EIGRP and configure OSPF in this topology. So I'm gonna remove that. I would say no router EIGRP 100, no router EIGRP 100. From green go to configuration mode, no router EIGRP 100. That's it. Now configure DMVPN Phase 3. We have the configure OSPF. Now configure OSPF here. Router OSPF 1, network ID or any address along with wildcard mask area 0, and we are defining tunnel mode point to multipoint. Go to red router and we are gonna define the same type of thing. Network 192.168.1.0, next 25, third is 2222. On interface tunnel IP OSPF network point to multipoint on green router. And that's it. Interface tunnel IP OSPF network point to multipoint, and we can see that our hub router formed neighborship. I'm gonna disable all this, debug message, undebug all, and let's say show IP OSPF neighbor, and we have two neighbors. Go to green router and verify, do we have any route for another spoke. So I say 2.2.2.2. Okay, so this time you can see I already learned about 2.2.2.2 known via OSPF. We are running OSPF point to multipoint. The same scenario I have DMVPN Phase 3 with EIGRP. Now I have DMVPN Phase 3 with OSPF, but we can see the difference. In EIGRP we generated default route from hub and we had a new route installed in the routing table, but here we are not generating any default route from hub, and we can see that we are learning 222 via OSPF. And who is my next hop? The next hop is this. So the next hop is not preserved, it's updated by hub. If I say trace route 2.2.2.2, if I want, I can send packet, and that will first packet will go to hub and the next packet will go to red router. So what this routing table is saying in green router, you have learned this route via OSPF, but there is a difference in another table which we are using this time. It's called show IP SEF. And show IP SEF says if you want to send packet to 2222, right now next hop is 1.1.1.1, but let's try to trace route, then verify later on if we see any update, because currently you see the routing table and the SAP table both are identical, they are pointing the same next hop, but after tracing the route we can see something else in the table. Let me try one more time. This time packet must directly go to red router. We can see that it's going directly, and this time again I verify show IP route 2.2.2.2. This is pointing to this next hop. If I say show IP SAF, and here is the difference. So SAF is saying something else and routing table is saying something else, but we are actually forwarding packet based on this SAF table. The SAF table is saying you can directly resolve this IP over the tunnel. So here is the most important thing to pay attention, because RIP and FIB are not synchronized, but this is not a bug, but we wanted this type of behavior, that is the behavior here. And also in EIGRP example we saw that NHSRP route is installed in the routing table. In this OSPF example instead I don't see it in the RIP. So if I want to say show IP route 222, there is no route installed in routing table, but there is a new update in SAP table, which both I can see the routing table and SAP table both are not synchronized. So a scaling issue if I use OSPF point to multipoint over DMVPN phase 3 is that for any new destination I will have a resolution process, and that installs a NHSRP route in SAP table. So the number of destination, the number of SAP entries you are gonna have. So that can be a problem for router, for resources of router in term of memory space. So this is the process of DMVPN phase 3 using EIGRP, using OSPF. Let's trace route one more time, 2.2.2.2, and see that. So the packet first should go to hub, but that resolution already occurred. This time is directly going to the next hop. If we see the routing table, show IP route, we can see something else here, and that's the most important thing, is this percentage value. The percentage value representing means you are overwriting the next hop in SAP table. So whenever you see percentage value here, that means for this particular destination we have the next hop is hub, but actually if we see the SAP table we have the next hop is direct spoke. Okay, I think this mark represents or tells me that NHSRP is overriding the RIP info, and that is in OSPF, and this is in the forwarding table. And I hope it has been informative for you. Thank you and bye bye.